Jai Hind to all. Myself Shikha Agarwal, Assistant Professor in IT Department. Today we are going to talk about one complex topic of computer networks, that is error detection and correction methods. Right? So before we know why we are talking about the error detection and correction, or mean to say we talk about the error control. So first of all we should know that when we are talking about the data link layer in the computer networks, then it means we are talking about the position of the data link layer. In the case of data link layer, there are the certain duties and responsibilities of the data link layer, like packetizing, flow control, media access control, addressing, and one of the major responsibility or the feature of data link layer is error control. So in this lecture today we are going to discuss about the error control. When I am talking about an error control, it means there is some problem occurs during the data transmission, due to which we have to talk about the error control, right? So after that, in the case of error control, we are the two ways. Either we should detect the error, then after that, if we detect the error, then if there are certain chances to detect the error, after detecting it, we can correct the error also. So in this case, when I'm talking about data can be corrupted during the transmission, right? So whatever the data we are sending, it can be corrupted any amount of time. Fine. So due to which during the transmission, first of all, we have to do the certain requirements that the error can be detected and corrected. So when we are sending the data during the transmission, there are some applications that require the errors to be detected and corrected. Some applications can tolerate a small level of error. If there is a very small of error, like there is a single bit error or so on, so into that case we can easily tolerate the level of errors. For example, suppose we are sending a video transmission data, right? So in this case some error is to be tolerable, but in the comparison to that, if we are transferring the text data, in the case of text data, we require a high level of accuracy. When we require the high level of accuracy, into that case, we need to maintain the error detection and correction method. So now here, first of all, we are going to talk about the certain issues which is directly or indirectly related to the error detection and correction methods. So first of all, we are going to talk about what are the types of errors. Whenever we are flowing a data, whenever the bits will flow from one point to another, there is subjected to be predictable, there is a certain changes because of the inference, right? Inference means we can change, there is a change can occur the shape of the signals. So for example, if we want to send a data of 11100 burst of impulse noise on a transmission with a data rate of 1200 bps, right? So there may be a change all or some of the 12 bits of information. So into this case, the sum, when some bits is to be changed, then we can say we are talking about the errors. Now there are the two types of errors. The first, we are going to talk about a single bit error. In the case of single bit error, only the one bit in a data can be changed, right? So you can see the example also. This figure shows, suppose we want to send this data of 8 bits, for example, 5 times 6 times 0, 1 0, right? After sending this data, when it comes to the receiver's end, the fifth bit of the data is being transformed from 0 to 1. So somewhere there is a change into the data. So this particular example is the single bit error. The second type of an error is a burst errors. Burst error says when we are having a change into the data unit of 2 or more than 2 bits, then we talk about the burst errors. Now you can see the example. Suppose the sender wants to send the above data, and out of that above data, if we talk about the range of 8 bits, or in the case of 1 byte data, the length of the burst errors, into which n number of bits, like in this example, the 4 bits is being corrupted. They have been changed from 0 to 1 and vice versa on the receiver's end. Then you can say this example is called burst error. Now, if I'm talking about the error detection methods, In the case of error detection methods, first of all, we should know how we can detect the data, and simultaneously we should know what do you mean by the term redundancy. Whenever we want to detect or correct the error, so we need to add or we need to include some extra bits with the data, that is called as a redundant bits. And the process in which we are including the redundant bits within the data, then that is called redundancy. So whenever we are detecting or correcting the errors, into that case we need to include the certain extra bits, or that extra bits are called redundant bits, right? Now you can see when I am talking about the structure of including the redundancy bits, right? Whenever we talk about this data transmission from the sender towards the receiver side, then we can say in the case of sender side, first of all the data or the message is being encoded by using the encoder, and on the receiver side, whatever the message we have received, it should be decoded. So into this case, whenever the sender generates the message, it generate the message, then encode the message by using the generator function. Whatever the generator, it varies from different ways. Then after that, it will send a message plus redundancy data towards the network. So we can say whenever the sender will send the data, it will send message plus redundancy bits, right? And when after that, this data is to be transmitted on an unreliable transmission when it comes to the receiver's information. Now the receiver will receive the message plus redundancy bits, right? After receiving the message plus redundancy bits, or you can say it is also called as a receiver's information, then after that it includes the checker function. There is a similarity between the generating function and the checker function. There is a coordination between both the functions. Then after that, it will check whether the message is correct or not. If the message is correct, then it will accept the data, right? If the message is correct, it will accept the data. Otherwise, it will discard the data because it is already corrupted. So it will check whether we can correct the data or not. Fine. This is the structure when we talk about the encoding method. Now, when I am talking about the redundancy checks, so there are the 4 types of redundancy checks. First is VRC, that stands for vertical redundancy check. The second, we are going to talk about LRC, longitudinal redundancy check. The third method is CRC, that is a cyclic redundancy check, and the fourth is checksum, right? So in this, we are going to talk about all these 4 redundancy check methods, which is also called as an error detection method. And in this, we are going to discuss a one example of each, right? So first of all, now before that, we should know how it is being generating a error detection process. In the case of error detection process, whenever we are sending the data word which is of k bits, right, we have to apply the generator function. In the case of generator function, it depends which type of a method we are using, VRC, LRC, CRC or checksum. Whatever the method we are using, each and everywhere the generator function varies. Then after that, we have to generate the code word which include the n bits. It means it comes to be calculate k plus n bits when it comes to the unreliable transmission. And after coming to the unreliable transmission, into this code word, finally it will receive the particular bits. Now here we will include the checker function. After including the checker function, it will, if it is correct, right? So if it is correct, then it will accept the data word, or you can extract the data word from the function. And if it is not correct, then it will discard the data. Fine. This is the way how the error detection method works. So similar diagram we will use in all these 4 methods. Fine. First of all, we are going to talk about VRC, vertical redundancy check. This is one of the most common and a least expensive mechanism for the detection of errors. This is the most common or basic method also. Now here what we have to do, we have simply do the sum of ones in the data. How many number of ones exist into the network? We have to check how many number of ones in the data. So basically in this technique, the redundant bits, or you can say, which is also called as a parity bit, is appended to every data unit so that the total number of ones in the unit becomes even, right? That is why the generating function or the checker function is called as parity generator. In the case of VRC, we are using a parity generator, right? Whenever we send the total number of bits towards the receiver side, we have to send the message bit as well as the parity bits, right? Into this case, even if it is an even parity, even parity says if it includes the even number of ones, right? If it is a even number of ones, then we say have to include 0 as a redundant bit, right? And if it is an odd parity, right, it means odd number of ones. Then we have to include 1 into the data, which is called as a parity bit, right? Now you can see the example. Suppose if I am talking about this message m is equals to 11 4 times 0 1. We wants to transmit that data into the network, right? When we are sending this type of a data into the network, we have to apply the process of encoder and decoder into the network, right? Into this case, first of all, suppose on the sender side we wants to send the data, right? First of all, it will generate the data word. Data word is already given 11 4 times 0 1, right? After that, we have to apply the generator function. So here we have to apply the parity generator. In the case of parity generator, it will check the even odd parity. Okay? So here we will use the even odd parity generator, right? Then after that, it will calculate the sum of ones in the data. Here we came to know that there are the 3 ones into the data, 1 2 and 3 ones, right? So after that, it will generate the code word. So while generating the code word, it will include the redundancy bits. After including the redundancy bits, to make it even, then what we have to do? We have to include 1 in the data, right? When it comes to the unreliable transmission, in the case of unreliable transmission, it will send the redundancy bit, right, and the data word. As I have already told you that it will send a message plus parity bit towards the receiver's end. When it comes to the receiver's end, receiver use the checking function, right? Here we will use the checking function. In the case of checking function, it will check whether the data is having an even number of ones or not. Yes, it is having an even number of ones, so it will extract the data. So finally, we will get the data word. It will exclude the redundancy bit and we will get the final result. So we can say whatever the data is being sent towards the center side, finally it comes to the receiver's end. Fine. So this is the way how the VRC works. Now after that, the second method is called longitudinal redundancy check. Whenever I am talking about a longitudinal redundancy check, there is a block of k bits. Remember one thing, whenever we are talking about a longitudinal redundancy, basically it is giving a more complexity. So due to which, if we are having a data is of k bits, so into that case, what we have to do, first of all, we have to convert into rows of equal size. Then simultaneously, whenever we are sending the message, so message plus redundancy bits, we have to transmit the data, right? So when I'm talking about the longitudinal redundancy check, it increases the likelihood of detecting the burst errors, and simultaneously redundancy of n bits can be easily detected a burst error of n bits. So therefore we can say one pattern of errors that can be exist. If there is 2 bits in the data that is are damaged, then we can say checker will also not detect that type of an error. Fine. Now again you can see the example. Suppose if I am talking about the longitudinal redundancy check, in the case of longitudinal redundancy check, whenever we are having a message, right? Suppose this is a long message is being given. Fine. So first of all, what we have to do, we have to convert this particular message into the k sections of each row. So we can check all these numbers is to be converted into this manner. So we have to convert into the all parameters, right? So this particular data is being converted into the this way. Then after that, what we have to do, we have to calculate the generating function. Then using the generating function, we have to apply the function. So in this way, now we have to write each and every row into the column way, right? So we have to include into the rows way. Then after that, we have to write this way: 1 1 0 triple 1 0 1. Then this column into the next row, that is a 0 0 triple 1 double 0 1, and finally the last row is 1 0 1 0 1 0 0 1. Fine. Now after writing into the k sections of divided into the k sections of rows, then after that we have to apply the even odd parity to make it even, right? So suppose if I say, then we have to calculate into the row wise. 4 times 1, then it is an even number, so we have to include 0. Then there are the 1 1, then 1, then 2 ones, then 0, then 3 ones, 1, then 2 1 0, then 3 1 1, then 2 1 0, then 3 ones we have to include 1. So this is called as a redundant bits. Fine. After this is to be done on the sender side. Now from the sender, it always sends message plus redundant bits, right? Now after that, when it comes on the receiver side, this is a complete message which I have already written, and you can check this is your redundant data, or you can say redundancy bits, which is already we have generated in the question, right? Then after that, again we have to follow on the receivers and the same process. Again, the receiver also divide the given data into the k sections: 1 1 1, 0 0 triple 1, then this into the next row, that is 1 1 0 triple 1 0 1, then again into the next row 0 0 1 1 1 0 1, then the next into the next row 1 0 1 0 1 0 0 1, and in the last what we have to do, we have to also include the redundant data as a data into the code word: 1 0 1 0 1 0 1 0. Now what you have to do, you have to apply the checking function, which is also an even odd parity, right? After that, if you include, we can calculate, these are the 4 ones, 0, even ones 0, even ones. Finally we are getting the 8 times 0, right? So it means if all the code words is to be 0, so the data will be accepted, otherwise rejected. This is the way how we are talking about the longitudinal redundancy check. Is it fine? So these are the two methods. You can see when I'm talking about these two methods, the both are the techniques which is similarly based on addition method, right? So you can see VRC and LRC both are based on the basic method. This is called addition, right? But now we are not more dependent upon the simple addition method in which we need to check the even and odd parities only, right? So we are going to talk about the most powerful technique of the redundancy checking technique, that is called as a CRC. That stands for cyclic redundancy check. In the case of cyclic redundancy check, it is simply based on the binary division method. When I am talking about the binary division method, we know this is the way how we are doing the division, fine, in which dividend is being divided by the divisor, in which it generates the quotient, and finally we get the remainder, right? So in the case of remainder, this particular remainder is working as a redundancy bits, right? Dividend is a code data word, and divisor is a generating function. Fine. So this is the way how we have to talk about the cyclic redundancy check. Now when I'm talking about the cyclic redundancy check, on the senders, first of all we are going to talk about the sender side, then we are going to talk about the receiver side. First of all we are going to talk about sender side. Sender has a generator which is called as a GX polynomial. In the case of cyclic redundancy check, here we are going to talk about the polynomials. When I am talking about the polynomials, you can say the equation can be like x square plus 1x plus 10. So these are your polynomial equations. Then after that what we have to do, by generating function, in the sender side we have to append n minus 0 bits to the data word. Fine. Then where n is a number of bits in the generator, whatever the bits is being generated into the generator function, we have to subtract 1 and we have to append the 0 bits into the data. Suppose you can see the example. Suppose we have a generating function that is x raised to power 3 plus x raised to power 2 plus 1. So into this case, if we say 3 is the highest power, then we can say we are going to talk about the 3. Then the next power is 2. We have to go into the decremented way. So 3, 2, there is no x here. So we have to include 0 and there is some constant is there. Then we have to include 1. So we can say, if I am talking about the generating function of this equation, you can say gx is equals to 1101. Right? So it means we have to include the n minus 0 bits into the data. So due to which n minus 1, that is equals to 4 minus 1, means we have to append the 3 0 bits to the given data word. Suppose the data stream is already given to you. The data stream can also be given in a polynomial way also. So 100. So we have to include the 3 extra bits into the data word. Then after that we have the dividend appended data. The divided appended data means we have to include the data word as well as the extra bits. With the generator function, we have to use the modular 2 division arithmetic method. Then whatever the remainder is being generated, the remainder can be of n minus 1 bits, that will be the CRC, which can be included into the data and sent towards the receiver side. Fine. So let's see the example on the sender side first. When I'm talking about the sender side, suppose this is a GX is already given. So if I'm talking about the GX, then you can say GX is equals to 1101. Then in the data stream, that is equals to 100100. It means we have to append the 3 extra zeros. Fine? Clear? So after that, what we have to do? We have to talk about the division method. In the case of division method, dividend is divided by the divisor. Fine? Before we start with the division method, remember one thing. If the condition is 0, 0, then we have to include 0. If the condition is 0, 1 or 1, 0, then we have to include in both the cases as 1. And if the condition is 1, 1, then also we have to include only the 0. Right? So, first in this case of division, first of all, we have to check its first bit. If it is 1, then we have to divide it by the 1 only. So it becomes 1, 1, 1, 0, 1. Then we have to do the division 1, 1, 0, 0, 0, 0, 0, 1, 1, 1, 1, 0. Right? So we will cross this bit and copy the next bit from the upper side. Again, the first bit is 1. So we have to write 1, 1, 1, 0, 1 again. Right? 1, 1, sorry, 0, 1, 1, 0, 1, 1. 0. Cross. Then again we have to copy the next bit. Fine. Again we have to divide it by 1. 1, 1, 0, 1. 1, 0, 1. 0, 1, 1. 1, 0, 1. 0, 0, 0. Right. Then we have to copy the next bit, that is 0. Fine. Then what we have to do? We have to write as 1, 1, 1, 0, 1. Now, you can see the first bit is 0. So, if the first bit is 0, into this case, we have to write the 0 in the quotient. And in spite of copying the divisor, we have to write the 4 times 0. Fine? Remember this point? So, 0, 0, 0, 1, 1, then 0. To cross this value and finally you will copy the 0. Again, the first bit is 1, so we have to do the division. Right? So you can see we get the remainder as 0, 0, 1 because we have already appended the n-1 bits. So we are also getting the n-1 bits CRC. Right? This CRC is being generated by doing the division method. Now, when we talk about the receiver's end, the receiver always get the data stream plus CRC. So now they will get 1, 0, 0, 1, 0, 0, 0, 0, 1. This is your CRC bits. This will be your data stream bit. Fine. So now let's talk about the receiver's end. Remember one thing, receiver always use the same generator function, that is GX. Then the receiver divides the received data. The data is to be data plus CRC with the generator. And if the remainder is 0, then the data is correctly received, else it shows that there is some error. Fine. So if we talk about the receiver's side, we will do the division. The data word was 1, 0, 0, 1, 0, 0. This is your CRC bits. Divisor was 1, 1, 0, 1. First we are going to divide by 1. Again, we do the same process. Right? So again, you will do the division in the similar way as we have did in sender side. Again 1 divided. Again 1. Now we will get again 2 zeros, 1, 1. So in this case, first 0 is cut. Then we have to copy the figure from the above. If it is again 0, then we have to do the 0 and we have to write the zeros. Fine. In the similar way as we did in sender side. This value is deducted. Now you can check 0, 0, 0 and 0. N minus 1 bits, that comes out to be 3 zeros. N minus 1 zeros. And all the bits are zeros. It means the data is to be accepted. Otherwise, the data is to be rejected. This is the way how we are going to talk about the CRC method. Remember one thing, when I am talking about the CRC, into this case, we are talking about the polynomial equations. It means the polynomial generating functions. There are the certain polynomial equations which is already being fixed. Like you can have a CRC 32, these equations CRC 16, these all are the generating functions which is already being fixed, like CRC 8 and so on. So these all are the generating functions which is already being fixed into the network. For example, I can explain you, if I am talking about CRC 8, the equation is x raised to power 8 plus x raised to power 2 plus x plus 1. This polynomial equation is being fixed in the case of computer networks. So there are the certain CRC methods which is already being fixed. Fine. When I am talking about the CRC, we can also detect all the burst errors of length less than or errors into the degree of this particular polynomial. So it means if the degree is 8, so we can burst out the errors, we can check the errors up to the degree of 8. Now the last method here, we are going to talk about the checksum. In the case of checksum, this is also the one of the method which is being used for the for the redundancy check. When I am talking about at the sender side, what we have to do, first of all, we have to divide the data into k sections and each are of n bits. N bits means similar size, right? Then after that, all the sections are added together by using the ones complement to get the sum. So we have to apply all the section addition of using the ones complement onto the sum. Then after the sum is complemented and whatever the sum is being complemented, we have generated the checksum. Then the checksum is being sent with the data towards the receiver side. So this is the way how the checksum works towards the sender side. Now you can see the example. Suppose if I give you a block of 16 bits is to be sent by using the checksum of 8 bits. Why? Because if it is a 16 bit, then of this data is word is of 16 bit. Right? So it means we have divided the data into the 8 bits. Okay? We have divided into the k sections, that is into the 2 sections, and simultaneously each section is of 8 bits. Then after that, what we have to do? We have to do all the sections are added together to take out the ones complement. So if we apply the ones complement onto the data, it comes out to be 1 0 1 0. This is your k section data world. Then after onto this data, we have to apply the ones complement. Once we apply the ones complement, then what happens? 1 1 0 1 1 0 1 1 1 1 0 1 1 1 1 1 then 1 then 1, right? So this comes out to be your sum. Okay, so you can say ones complement. After applying the ones complement, what we have to do to generate the checksum, we have to do the complement of ones. To generate the checksum, we have to do the complement of 1. Complement of 1 says 1 ka 0, 0 ka 1. 0, 0, 0, 1, 0, 1, 0, 1. Now, this becomes the checksum, right? So, after that, when we talk about the including this, then when we talk about the receivers end, in the case of receivers end, again, what they have to do, they have to divide the data into the k sections and each is of n bits, and all the sections they are added together using the ones complement to get the sum. Ones complement, whatever the sum is being generated, the sum is being complemented, and if the burst is 0, then the data is accepted, otherwise it is rejected, right? You can see in the case of center side, we have generated the checksum, right? So if the data word is this, so we have divided into the k sections on the sender receiver side, and simultaneously we have to include the checksum also. What was the checksum? 000 111 01. This was the checksum which is being generated on the receiver side, right? So what we have to do? Again we have to do the sum. 10 10 10 01 00 11 001. Now what we have to do is we have to do the sum. After doing sum, 111 1 1 1 1 111 1 1 111 1 1 111 1 1 1 1. We are getting the sum of all the data including the checksum, that is all times 1. Then what we have to do? We have to do the complement of it to generate the error, to check the error. So to check the error, we have to do the complement of the sum. This comes out to be 8 times 0. It means if the checksum comes out to be 0, it means the data is accepted. If the single bit is also 1, then we will reject the data, because there is some error into the data and we cannot accept the data, right? So these are the 4 methods when we talk about the error detection. Thank you.